Okay, guys, now we're on to tubular reabsorption. So just as a backup, if we back up and recall that this is all about renal clearance, right? We already did hepatic clearance last week, but this week it's about clearance by the kidney, which means the kidney is just moving the drug out of the body, right? It's not metabolizing it or doing anything fancy. It's just moving that molecule out of the body in the urine. So the first thing that happens is we have our blood flow to the glomerulus. So this is GFR times fraction unbound to get our GFR, or to get our filtration clearance. Q times E, right? And then drug, I'm going to change the color of this because now it's in the nephron. So this is now making urine, right? We have our proximal tubule, and in our proximal tubule, we have drug being moved from the blood now from the blood into the urine. This is tubular secretion. It's active. And you need a transporter to move from the blood into the urine or into the tubule. There's competition for these sites, as we learned in our tubular secretion section. And then the last thing that happens is we have tubular reabsorption. So now drug may be moving back out of the urine and into the blood, this is the blood here. I moved where the blood was. The blood is surrounding all of this, okay? So we have drug moving from the nephron back into the blood before it goes out in the urine. This is a passive process. It's the last chance for the drug to be reclaimed by the body. And so it's passive. It undergoes passive diffusion, and it is, like I said, passive. So it is a passive process. What that means is it happens without there being energy, and there's no transporters or anything that you can need Michaelis-Menten for that you could overcome. What's going to determine if a drug is going to move is going to be reabsorbed. So here's our blood, and here's our nephron, which is making urine. So we have our drug, and we have also some drug in the blood. If there's a concentration gradient, and if it's lipophilic enough and unionized, it will move by passive diffusion from the urine back into the blood, under the same rules as we have always had for passive diffusion. There has to be a concentration gradient. There has to be more drug over in the urine than in the blood. It has to be unionized, and it has to be lipophilic enough, and then it will try to equilibrate between the urine and the blood. Thereby, some drug will move from the urine over to the blood. That's it.